Okay, so here are some tips or review, if you'd like, as you start looking at proving trigonometric identities. So one of the things you want to do when you're starting off with a proof, when you're picking between starting with the left side or the right side, pick the side that's more complicated. That gives you more chances to manipulate things, more chances to try different tactics. But if you pick the simpler side, really there's not too much to do. So pick the side that's more complicated. Sometimes you'll have to work with both sides, but at least start with the one that's more complicated. And you want to start to look for some of the more popular identities that we can use to substitute or to try and simplify with. So one of them is that tan x equals sine x over cos x. And tan is a big one that you want to try and substitute out for, because often the rest of the proof doesn't use tan. So whenever you can substitute that for sine over cos, that's a good one to use. And then you want to look for chances to use sine squared x plus cos squared x equals 1. That's called the Pythagorean identity. You might also find it in one of its two other forms. You can see by rearranging it, you can see that sine squared x is equal to 1 minus cos squared, and cos squared x equals 1 minus sine squared. So any one of those forms is also something you want to keep your eyes open for. So in our proof that we started off with on the first slide, the left side is definitely more complicated, and we're going to start by taking out that tan x, because nowhere else is there tan anywhere in this equation. So chances are we don't want to leave this as tan anyways. So we're going to take out tan x and replace it with sine x over cos x. And then by a little bit of multiplication, we're going to multiply that sine times sine together and get sine squared x. So once we have that done to our work, this takes us to our next tip, and that you want to pay attention to how many terms we're working with at the same time, because keep in mind on the right hand side of this equation it was just secant x. That's one term. But on the left side, which is where we're working, we have two terms. Sine squared x over cos x is one term, and with the addition sign separating it from the second term, which is just cos x. So that's two separate terms. So how can I bring these together to make them into one term? Well, we need a common denominator because we're working with a fraction. So that second term, cos x, or cos x over 1, needs to have a denominator of cos x also, just like the first term. So we're going to multiply the numerator and the denominator by cos x so that we have a common denominator. And now we can take both of these terms and combine them into a single term. So we get sine squared x plus cos squared x all over one denominator of cos x. And it may look more complicated right now, but remember what one of our tips was, and that was to look for that Pythagorean identity. Sine squared x plus cos squared x equals 1. So now we can take out that entire numerator and replace it with 1. And 1 over cos is equal to secant. So that's exactly what we needed. That's our reciprocal. And we've now proven that left side equals right side. So we finished our proof for that equation. Another tip we have is that factoring can help simplify things as well. So in this other equation, we see we have two terms on the left-hand side, but we have sine in both of those terms, sine x minus sine x cos squared x. So sine is in both of those terms. So if we common factor out sine, what we're left with is 1 minus cos squared x. And if you go back a few slides, you'll see that again is one of those main identities that we can use to sub out. So go back, check to see what 1 minus cos squared x is equal to, and sub it in. And you're going to see really quickly that again here we're going to get left side equals right side in about one more step, which is a really neat way to end that proof. Finally, the last step is more of a warning, and that is that even when you want to start canceling things out, be very careful that you're only canceling between terms that are linked by multiplication. So right here, it may be very tempting to start crossing out sine from the top and the bottom and some of the coses from the top and the bottom, but they're linked together with a subtraction sign. We can't cross anything out here. So that's not a good way to try and reduce. You're going to get all confused and the proof is not going to work. You're not going to see left side equals right side. But what you can do is start thinking about factoring. And if you start with the numerator and treat that as a difference of squares, again, you're going to see really quickly that it will be able to simplify nicely And once you have factored it, you can start crossing things out because they'll be linked with multiplication. So that's a good tip for this question. You start by factoring using a difference of squares with that numerator. See if you can get this to reduce nicely, and you'll see that it actually does equal 1 at the end of the day. Good luck with that, and good luck with the rest of your proofs.